In section 3.5, we're talking about parallel lines and triangles. So first off, we have a postulate to talk about, and it's a little confusing to read it, so I'll simplify it for you here in just a moment. But it says, through a point not on a line, there is one and only one line parallel to the given line. Okay, we can dissect that and figure out what that's saying, but let me just go ahead and simplify it here a little bit. So if I take a look at a line, I'll call that line L. There's my line. Now, there are an infinite number of lines that are parallel to L. Okay? Infinite number of lines parallel to L. Remember, parallel means it's in the same plane and it never intersects. Right? So I could draw all sorts of lines that are going to be parallel to line L. Right? I could do that. Okay. But I could also say, well, what about the plane like coming out at us? Right? So I know I can't draw it on my tablet right now, but you could think, you guys are all looking at me now. Now think of a line up here where my pen is, above the screen, right? That could be a parallel line to line L. There's an infinite number of those, right? Okay. But that's not what they're talking about. They're talking about lines that are parallel to this given line passing through a specific point. Okay? So now, lines parallel to L that passes through that specific point. Well, there's only one of those. There's only one line possible. Now, there are lots of lines that pass through point P. In fact, there's an infinite number of them. But there is only one of them that will also be parallel to line L. Okay? That's what they're talking about there. Through any point not on a line, there is only one line parallel to it passing through that point. Okay? Questions on that? Anybody still confused on how or why or what that is saying? Because it's a postulate. I can't prove it to you, but I can explain it again if you need me to. I can try to explain it differently if you need me to. Looks like everybody's cool with that. All right. Well, then there's another theorem that I want you to look at. Another theorem I want you to look at. And that theorem is called the triangle angle sum theorem. The triangle angle sum theorem. So, the triangle angle sum theorem tells us that the three interior angles of a triangle add up to 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So what I want to do today is I want you guys to demonstrate this for yourselves. Okay, I think many of you already knew this, some of you maybe forgot this, and some of you maybe didn't know this at all. But this is always true, regardless of what the triangle looks like, regardless of anything else. This is always going to be true. The three interior angles of a triangle add up to 180 degrees. So let's take a moment to do a slight activity and talk about that. What I want you to do is I want you guys to all get out a straight edge. So you like your student ID or something like that, something that's a nice straight edge on it. And I want you guys all to get out a clean sheet of paper. Well, one of you and your desk buddies need to get out a clean sheet of paper, fold it hamburger style, cut it in half, give the other half to the person next to you. Okay? So get those things out for me, please. All right, so now that you have your half sheet of paper and you have a straight edge, I want you to very carefully, with a straight edge, make a triangle. Any kind of triangle you want. Okay? Any kind of triangle you want. But you need to be using a straight edge, folks. You do not want to do this without using a straight edge. All right, now with my iPad, it's a little difficult for me to use a straight edge, but I'm doing my best for you here.
There should be an effect though, like...
I know, but I wanted to demonstrate what you guys are supposed to be doing. But yes, there should be an effect that makes a triangle for me.
No,
Okay.
like demonstrate, like makes a...
Once you are done cutting out your triangle, I would like you to go back through and label each angle 1, 2, and 3. Okay, go back and write on each angle, make it angle 1, 2, and 3. Doesn't matter which order they're in. Just 1, 2, and 3. Okay? Once you have done that, you're going to take your wonderful looking triangle and you're going to tear it. You're going to tear each of your 3 angles off. I would cut it rounded. I would make sure it's a nice tear so you can tell. That's why we're labeling our angle, so we know which part is the angle versus which part is the tear. Okay, so as long as you can tell the difference, you're fine. Okay? So then just putting this on the video here, if I go through and put a straight edge up here, I'll draw it in blue. That's a horrible straight edge. Close enough. So there's my straight edge. I would be able to demonstrate or line these angles up in such a way that this would be angle 1, this would be angle 3, so that those 3 angles, angles 1, 2, and 3, fall on that straight line, that straight edge I have. Okay? So now what I'm demonstrating here, and what you guys would see if you had your cutouts in front of you, basically your piece of paper should have a ghost of a triangle on it now, right? As long as you didn't cut it into strips. You would have your piece of paper, then a triangle removed from it, right? Okay. Well, you would see that. You would be able to line up and say, all right, well, I know that this is an interior angle of my triangle, angle 2. This angle out here, a vocab word we'll use more tomorrow, but notice it's a linear pair with its adjacent interior angle, right? That's a straight edge right here. Okay? So they're a linear pair. This is called an exterior angle. This exterior angle is equal to angle 1 and angle 3 added together. Notice that? Angle 1 and angle 3 added together here. If I extended out this side here, so I'd have a straight line coming out here, the exterior angle made over here would be angles 2 and 1 added together, because I already have angle 3 here, right? They have to all line up, 1, 2, and 3, to make that straight line. And so on the other side. That is another theorem on the back side of your notes. Flipping to the back side of your notes, we have a theorem called Theorem 311. The triangle exterior angles theorem. So, the measure of each exterior angle of a triangle equals the sum of the measures of its remote interior angles. There's that vocab word. The 2 remote interior angles. We're talking about an exterior angle for a triangle. So an exterior angle is a linear pair with the adjacent interior angle. And that exterior angle is going to equal the sum of the 2 remote interior angles. And again, we really just demonstrated that with those triangles that we just did. Okay? We know, well, if this angle is already taken up on this straight line, then this angle must be made by the other 2 angles in our triangle. That's what we just did together. Okay? Questions? All right, so the key idea today is that the 3 interior angles of a triangle always add up to what? 180 degrees. Let's look at the example right above here. Look at the example above here. So, taking a look here. We need to solve for x, y, and z. We need to solve for x, y, and z. So, which variable can we solve for immediately? X. Is there another one we could solve for immediately? Because I asked. Sorry. No, it's z. Z is the answer. Okay. It's z. We can't solve for y immediately because we don't know x. We don't know. Oh, I take that back. We could solve for y immediately. How? That theorem I just talked about, right? The exterior angles theorem. I could say this. I say, well, wait a minute. I could say that y is an exterior angle of that blue triangle. Therefore, according to my exterior angles theorem, I'm going to say that y is going to equal 43 plus 59. I could do that. That's what that theorem tells me. Great. I could solve for x right away. Why? The triangle, angle, sum theorem. The triangle, angle, sum theorem says that the three interior angles of a triangle add up to what? 180 degrees. So x plus 43 plus 59 equals 180. Great. How could I solve for z directly? Anybody see that? Yeah.
You could kind of do the same thing, but with like the bigger outside triangle.
Oh, triangle ABC.
Yes.
This big triangle out here. But here you got to be careful. Z is definitely an angle in that triangle. 59 degrees is definitely an angle in that triangle. But this angle, angle ABC, is not 43 and it's not 49. It's those two added together, right? So that's what we would do. I could say, all right, I can solve for z by saying z plus 59 plus 43 plus 49 equals 180. A lot of people look at that and say, well, wait a minute, you got 4 angles added together. I thought there was only 3 angles in a triangle. Well, you're right, but these 2 angles are 1 angle in my triangle, right? Those 2 angles add up to give me that 1 angle in that big triangle. So there we go. I've got 3 equations. Let's go ahead and solve these quick. Starting out with y. Y is going to equal 43 plus 59. What's that give me? 102. Y is 102. Great. Let's go over to x. X is going to be x plus, well, wait a minute. 43 plus 59, we did that. That's 102. Subtract 102 from both sides. What's x equal? 78. Great. Going over here to z. I need to take 59 plus 43 plus 49. 151. When I add those up? Okay, and now I'm going to subtract 151 from both sides. So what does z equal? Say that again?
29.
29? All right. Well, let's see. We could check our answer. We could check our answer because I know that the 3 angles of a triangle have to add up to 180 degrees. So let's test this triangle that we didn't use. That triangle we didn't use. Take your calculator. Take 49 plus the y value is 102 plus the z value is 29. So 49 plus 102 plus 29, do we get 180 degrees? Yes! And so we can assume that. We must be right with all of our answers. Another way we could have found y, we could have said, well, once you find x, if you found x first, using the triangle angle sum theorem, you can say, well, y is a linear pair. You can do it that way. If you found z first, you could find y by using the triangle I have highlighted here in yellow. Again, triangle angle sum theorem. Okay? Lots of different ways to find these problems, or find these angle measures. Any questions on doing that? Okay, then it's homework time.